Hello everyone, I'm Mike Maniscalco with HEGI. Today's webinar will be part of our Networking Essentials series. This is our Intermediate Networking Essentials course. We also have a basic and an advanced course, but this today will cover intermediate topics around network troubleshooting and diagnostics and things like that. If you haven't heard of HEGI before, hopefully you have. HEGI is pronounced HEGI. It's a very, very common question. We've been in business since 2009, so we've been around a while. Kind of lead the category for brand leader and remote managed services the last few years. We won some awards, and hopefully you've read about us in the press. In this webinar, basically, this is what we're going to cover. By the end of this webinar, I want you to be able to walk away, number one, knowing who HEGI is and how do you pronounce the name. Hopefully we've covered some of that. Understand the growth of the network and the importance of the network. Know residential networking best practices. So a lot of what we're going to talk about is how you can apply enterprise-grade networking practices to the residents and what is different in a home network. So a lot of this focus is on a home or small business. We'll talk about common network issues you'll have and how you can troubleshoot those. We'll talk about the impact of latency and packet loss on network performance, what you can do to diagnose and solve those problems, what tools to use for remote access and support. We'll talk basic high-level VLAN principles so you know when to use it and how it works, but won't get into configuration of VLANs today. There's not enough time for that. Talk about the need for SNMP and how you can utilize that to get better visibility into your installations and your products. Talk about additional training, because with this networking topic, you can learn so much more, and it's always changing. So I'll point you in some directions of other training resources. And then we'll also talk a little bit about network security and password security and best practices around that. So we're going to cover quite a bit, as you can see. Given that we're going to cover quite a bit today, this is not going to be a HEGI commercial. We try to reserve these for educational topics and cover as much about how we can help you with networking knowledge and not talk so much about HEGI. Now, HEGI does play a big part in a lot of this, so we will talk where HEGI fits in, and I will give you a quick intro to what we do. But outside of that, if you want to see an HEGI demo, please go to ihegi.com. Right on the front page, you can schedule a demo. We can do a one-on-one demo with you at your convenience. So today, we're not going to get into pricing and how you sell it and what it consists of and do a full demo of the system. We'll talk some high-level features, but that's about it. So first, I do want to introduce our solution. This is kind of my quick pitch. If you don't know what HEGI Envision is, HEGI is a cloud-based remote networking management system. It helps you manage your networks remotely so that service and support can be done off-site without having to do a truck roll and go to your customer sites to troubleshoot every single network issue. We'll talk why that's important in a minute. It's very simple and secure. It works across multiple vendors. It's very inexpensive as far as an enterprise-grade networking tool will go. And it's also zero maintenance because it is cloud-based, so you don't have to worry about upgrades or maintenance or patches or ongoing fees. For upgrades to new software, we take care of that with the annual fees. So that's HEGI. It's a hardware-software combination. Again, ihegi.com, you can schedule your demo. So getting into our webinar here, let's talk about a typical small network that if I asked you to raise your hand, I would guess that 90% of you say, we have done jobs like this. And this is becoming more and more common, where the customer calls and they say, well, we need a network hooked up. We need a wireless access point or two. We want to hook up the Apple TV to it. I've heard you can control it with your iPad. You upsell them to Sonos and maybe put an IP power product in there. Right? It's a pretty straightforward job. The challenge with this job is that to support this customer when they have problems, it's a nightmare. Without the proper tools and visibility and training, it's very, very difficult, because when the customer calls, and it's typically Friday night, unfortunately, they're calling and saying, hey, my network's not working. I can't watch Netflix. And you're saying, okay, well, I'm going to help you troubleshoot over the phone, but there's only so much I can do. We might have to come out there tomorrow. And you talk them through a few things and realize this is not something you can do over the phone. So you have to drive out there Saturday afternoon. You find out that it was something as simple as Time Warner wasn't doing its job, or Time Warner was down at the time. It could be more complex. It could be the Wi-Fi had interference. Could have been user error. It could have been the Apple TV locked up. There's a number of issues that could be causing that experience to be ruined for the customer. But without the proper tools, you have no visibility. And this is a basic job. This is a simple job. The challenge here is every minute you spend on this job under warranty is money out of your pocket. So when you're not making a lot of money on products like Apple TVs and Sonos receivers, that's a big liability for your business. And really what your jobs typically look like are more like this, where you've got 20 to 25 devices on that network, and that support challenge just becomes even greater. Now you're stuck trying to figure out, well, where is the problem? And is the problem caused by another device on this network? And is something like power interfering with the performance because it's sending something online and offline constantly? So troubleshooting this network becomes more difficult. And looking forward to the future, that network is going to get nothing but more complex. So today we're about 10 billion devices connected to the internet. By 2020, we're looking at 50 billion, meaning your networks are going to increase in connected devices by 5x in the next 5 or 6 years. That picture is going to get more and more complex. And we talk about what else is happening in the world with the growth of gigabit internet, which is 1,000 times faster than today's average internet connection. It enables high bandwidth streaming services like 4K. And when we talk about network performance and why it's so critical to deliver that 4K experience over the network, you need to have the right tools, the right equipment, the right training and knowledge to deliver the throughput that you need. So we're going to talk a lot about those different tools. This is our intermediate course, so I'm not going to spend a lot of time on this, but generally your routers, your cable modems, your firewalls, your switches, your access points, your controllers, they make up your core networks, and hopefully you guys are selling all these products today. What I want to encourage you to do, though, is not go and buy an off-the-shelf, all-in-one router, cable modem, firewall, and access point and stick it in your customer's site and expect it to work the way it's supposed to. And that's what I want to highlight here. These are all independent items, and you should be selling commercial-grade equipment for each one of these items. So no blue boxes from the big box retail store in your customers' homes. You need to be looking at commercial-grade or better equipment. And a common question we get here at IHEJI is, what do you recommend? And that's a tough one for us to answer, because at our company, we really try to be brand agnostic, because we realize you want to pick best-in-breed manufacturers, and oftentimes you switch manufacturers 2 years later or because something's out of stock. So we work with almost all commercial-grade networking equipment that supports SNMP as a standard, which we'll talk about later. But companies you want to think about in the space are Cisco, Ruckus, Planet, Netgear on their Pro line, Microtech, Draytech, SonicWall, companies like that, companies with big names who have been doing IT for a long time. And if you're having to go down from this, you need to really consider it, because it's expensive to make that mistake on the network, and the network is critical. There are specialty vendors within our industry that do provide product. I think some of them provide very good services. Just talk to them and understand the trade-offs between those products. There are also 2 other things I'll plug real quick. We have really good relationships with both Access Networks and Reboot, and they provide services directly to audio-video integrators, and they typically install Cisco enterprise-grade equipment. If you want the upsell, which I really highly encourage you to have as an option for your customer, to enterprise-grade networking, if you're going to sell and install something like a Cisco enterprise-grade router and switch and don't have a highly trained person on staff, don't do it without help. Leverage one of those companies, because it is a different game. It's a different animal. Configuration is very complex. One little setting can throw everything off, and a lot of it's command line. So that's my one little note. So Access Networks and Reboot, if you're going enterprise grade fully up to that Cisco level, consider that. The SG500, SG300 from Cisco, those are something you could probably manage on your own, but if you're going 19 or the 2900 series or 3500 series switches from Cisco, that's when you want to think about it. There are a couple quick questions. Luxel is on the entry-level side of commercial grade. It's definitely price competitive with some of the off-the-shelf products that's where it's good. It doesn't support SNMP on all their products. I know that's something they're working on. So today it's hard for me to put them on this list, but it is a step up. If you're going to step up from big box, that's a step in the right direction. Package does support product as well. I would not call them enterprise grade. I'd say they're more commercial grade. We work with package products as well. So just investigate your vendors and pay attention to them. There is another question, and this is a common one. Apple Airport gear, I would not recommend it. That's off-the-shelf consumer-grade equipment. And Apple spends billions of dollars in R&D. That money is not spent on networking equipment. It's spent on watches and iPhones and MacBooks. If you look at their balance sheet and look at what the networking equipment is bulked under, I think it's bulked under peripherals, and you look at that percentage of their business, it's really, really low down the totem pole, which just means they don't focus a lot of engineering on it. So I would steer you away from that for a number of reasons. Another good reason is the Apple Airport Express stuff is very, very difficult to use off-site and to do changes in troubleshooting and configuration off-site, and that is a top priority going forward. So if you can't remotely manage something, it probably shouldn't be in your customers' homes. Arachnus is another product that didn't make this list, but yes, I would say that's that entry-level commercial grade, and we work with that as well. They do support SNMP. So these are just a few. We do have a reference network which we put together to help you pick equipment. I mentioned Access NY Reboot, but the Arachna stuff, Planet, Netgear, SG, 300, 500, 2900, 3500. As far as managed switches go, this is the step up. I would say this is the high end. This is the entry level points. Here's a few router options. Peplink seems to be more and more popular because it is a pretty easy to use interface out there. SonicWall also makes a good mid-grade router, but you need to be trained on it. Ruckus is by far the most popular Wi-Fi solution out there. And then if you're going to do any of this, make sure you're looking at IP power management, Minuteman, the RPM 1521, the Snap AV, Wattbox 200, 300. Put those behind your cable modems and routers. There's no good reason not to. So moving on from there, from the hardware, because I think that's something everybody always asks about. So hopefully that helps clarify some things. What are some things that you guys need to be thinking about in a residential integration network? Number one, I would always use managed switches. And the reason I say this is because a managed switch gives you so much more as far as visibility, control. When you do have problems, it's going to allow you to dig in those problems and really understand where they're occurring. Managed switches also give you the ability to, if it's PoE, power cycle ports and power cycle things on those ports remotely, which is really important. So managed switches are not something to be afraid of. Get trained on one, stick with one. Once you're trained on it and know how to use it, it'll work like a charm. Standardize an IP scheme, so you're using the same IP scheme from job to job. That's something I talk about more in the beginner networking course, so if you haven't watched that, go ahead and check that one out. I think that all IP-enabled devices should be on the network, behind your firewall for security, but they should be on the network because it's a software world. Everything relies on software updates. Firmware updates add new functionality to it. The ability to remotely troubleshoot and access and program is key. Think about networking-enabled printers. Hopefully you're all doing that at this point. Monitor app-type devices. So anything the customer is going to call you about on Friday night or on Saturday night when they're trying to watch a movie, but it's likely to be broken, that's something you should pay attention to and monitor it. So you can try to catch that break before it's Friday night. So you can catch it Thursday afternoon and take care of it before the weekend. Always consider IP-based power management. Whether you're doing the managed PoE switches or Bluebolt or Wattbox or whatever it is, use IP-based power management on your networks because these devices lock up, and remote rebooting of this type of equipment is important. Put in sequential reboots for your cable modem and router. So if the cable modem goes down, it does that sequential reboot. Put in a max number of retries. Make sure you're logging it and getting notified when it happens. You don't want it to be doing this blindly, and don't get too aggressive with it. But on the cable modem and router, I think that is a good thing to do. It'll save you a truck roll. We are dealing with a third-party router a lot of times from the ISP, and it will lock up occasionally, and we have no control over it. So when it does, having the ability to auto power cycle and try to fix it without driving out there is important, I think, especially as we scale. I wouldn't do automatic reboots for a lot of other devices, though. That's the one exception I kind of make for that. So assign non-floating touch panels to a single IP with a virtual SSID. This is becoming less important if you're using wireless controllers because that really does better manage the wireless network. But if you're not using controllers and things are prone to jump around the access points, it could impact the experience. So assign it to a virtual SSID at a single IP. If you're still doing that, you may want to consider a controller-based solution. Is probably the better way to go. If you're doing things like Apple TV, Blu-ray players, they have to comply with ENERGY STAR ratings. They turn off the Ethernet port in power save mode, and this does two things. It makes it really difficult for you guys to turn that on through control if you're doing IP control and the Ethernet port's off. So that's one reason you want to turn off energy savings on those. The other thing, if you are monitoring it and managing it remotely, if it's in standby mode, you're kind of locked out. So I would recommend turning that off in those types of devices. Plan now for the future for connected devices for 4K within the home, 10 gig Ethernet's coming to the home eventually. Think about those types of things and what infrastructure and cabling you're running. It's hard to future-proof with cabling. So yes, I could say run fiber throughout the house, but I don't know that that's the right answer. So what I would recommend is doing fiber between your main equipment locations and your demarcs and your equipment closets. So I'm sorry, did I say? I meant conduit. Run conduit so that if it's fiber, you can pull fiber later on. If it's Cat7 or something else, you can pull that through there. But conduit is as future-proofed as you can get. Consider remote PCs for programming if you're doing off-site jobs. Raspberry Pi is a great one. Don't put in spinning hard drives, do SSDs, just because you don't want things to die in the field that move. So if it's a remote job, that's really important. If it's a larger job, that can be important. You don't have to do it for every job. That's really where IHG is helping you out. But for some jobs, that can be really helpful. It also helps with remote firmware upgrades, which I think is important. If you have a remote PC on site, it's a lot safer to do remote firmware upgrades. Some other best practices in your world from an external perspective, block WAN ping to your routers. And what this means is if a middle schooler is running a script in your neighborhood trying to find out who in his neighborhood he can hack, he's running that script, and the first thing it does is try pinging all the IPs in the neighborhood. If you have WAN ping blocked, you're somewhat transparent to that check, and it'll move on to the next one, and I guarantee half your neighborhood is not doing that. Therefore, it's kind of like, I equate to, it's like locking your gate. If you lock your gate in your front yard and somebody's coming through trying to burglarize backyards and yours is locked, they move on to the neighbor. Management remotely should be limited to the IP address of your office or turned off entirely. So if you're allowing somebody to log in to that router remotely through port 8080 directly without VPN or anything, limit the IPs that connect to it. I would recommend just turning that off altogether and using IHG and or VPN to allow you to do that. It's more secure. Change your usernames and passwords. Don't make them the same for every single job, and don't share those with your entire company. Change the defaults. Document those in a secure password management tool, which I'll talk about at the very end. A lot of guys I look at don't do secondary DNS, and I think this is really important to make sure it's set. Because if you don't have a secondary DNS server, the primaries, especially local ISP primary DNS servers, do fail, and they will go down for maintenance. And when they do, the customer can't check their email, and their iPhone stops working to do whatever they were doing. That becomes a big problem for the customer, and it's out of your control. If you set a secondary DNS, it rolls over. And two highly available, higher-level DNS servers are 4.2.2.2 and 8.8.8.8. You can set those as your failovers. That way, if it is a local ISP issue, it fails over. What will happen is it'll be a little slower to query for DNS, but at least you won't get the phone call saying it's down. If you're not using DynDNS or Dynamic DNS services already, consider that. DynDNS.org, OpenDNS. Google has a DNS service, I believe. So check those type of things out. It really helps for remote access and remote support. Internally, what you want to think about is, again, standardizing your IP scheme, so all of your cameras are in the same group of IP addresses in every single job, and all your processors are in the same groups. We have templates for that, so if you don't have it, let me know. Static versus DHCP. This is a big one. If the device is important enough for you to monitor and troubleshoot, it should be in a permanent home on the network, and you can make it permanent in two different ways. You can set it to a static IP, or you can do DHCP MAC address reservation. Regardless, you should do one of those two things. It should be in the same place every time you log in, so that if the customer is having problems, you know exactly where to look. You don't want it moving around and having to spend 10 minutes just trying to figure out where it is. So I always recommend either static IP addresses or DHCP MAC address reservation for anything important enough for you to monitor and manage. The kid's laptop, the kid's iPad, probably doesn't matter. Leave that on DHCP. That's what it's made for. But your devices and your things that are delivering the audio-video experience or control experience need to be set to one of those two. If it's got SNMP, look into enabling it and look into monitoring it. That's really important. If your manufacturers aren't supporting SNMP yet and you want to monitor it, lean on them to consider implementing that in the future. It allows for better remote management. And then most importantly, document everything. Document it well. Keep it up to date. That's a really, really important thing with the network, especially as we add more and more devices. So the next thing I want to talk about are common network problems that you guys will probably run into in the field. The first one, you didn't set a gateway. So on one of the control processors, somebody forgot to set up the default gateway. And what that means is that device no longer has a route outside of that local network that it's on. So if you're on a different VLAN or you're trying to come in outside from the outside world and do remote programming changes on it, you can't connect to it. But if you go to the site and you're on the same network, you can connect to it on the network. That's what happens when no gateway is set. So always be sure to set a gateway. Programmers especially, a lot of times will forget to set the gateway. They're on site, they load everything, everything works, they leave, they try to make a program change remotely, nothing works, and they point fingers at the IT guy. But in reality, somebody just forgot to set a gateway. No DNS or secondary DNS. Always set a secondary DNS. That's, again, a best practice. It can help overcome problematic internet connections. We see a lot of network latency issues and packet loss issues, and this is something you want to pay attention to. And I'm going to get into a lot more detail, but what high network latency and packet loss means is that your switch is potentially overloaded or failing. Your ISP is having problems. You have bad wireless. You've got a bad cable, or maybe it's just entirely offline. Those types of things are something you need to pay attention to. And all this impacts network throughput, and I want to point this out before we start, is that Netflix recommends 3 megabits per second throughput. To get DVD quality, to get HD, they recommend 5 megabits throughput, and to get 4K, it's 20 to 30 megabits throughput. And what we're going to talk about next is the implication of packet loss and latency on your network throughput. So packet loss is the amount of time, packet loss is if I send out 5 packets, I should get 5 back. I should get out 0% packet loss. I should not get 4 out of 5 packets lost and get 20% packet loss. So packet loss, if I send 5 back, what percentage come back to me? Latency is how long those packets take to get back to me. And on a wired Ethernet network, it should be a matter of single milliseconds or less than a millisecond. As you get wireless, latency goes up. As you introduce the internet into the picture, latency goes up. As you introduce distance and you're crossing oceans, latency goes up. But locally, latency should be as low as possible. And then jitter is another measure that if you're doing voice over IP systems is something you want to pay attention to. But that's basically the variation in latency, because latency should be fairly constant. If I ping the internet and I'm getting 20 millisecond latency, I should get that pretty repeatedly. 20, 21, 20, 21 shouldn't be varying very much. If it is, it can cause bigger problems. So what does latency and packet loss do to your networks? This is really, really important for you guys to understand, because this is the #1 thing that we see on networks today. And the problem is you guys installed a nice gigabit switch for your customers 7 years ago or 5 years ago. And since then, you've added a HD IP camera and another one and an Apple TV and then an NVR and 2 more cameras. And all of a sudden, there's so much streaming traffic on there that the switch can't keep up, but nobody knows it. So the video's pixelated when things are streaming and capturing. And all of a sudden, things will go up and down and not work properly. And the customer gets frustrated. He puts volume up 5 times, and it takes 30 seconds, and all of a sudden, it's too loud. Those things are caused by latency and packet loss. And the reason this happens is because that switch is overloaded in that case. But I want to talk about what this latency and packet loss can do to your networks. If you have 0% latency and 0 packet loss, you should be getting on a 100 megabit network about 93 megabits per second throughput, because there's some, just physics, you lose some energy initially off the bat. So 93 is kind of, 94 is kind of your target at a perfect network. Now, if you were to introduce just 2% packet loss into that perfect network, your throughput goes from 94 megabits per second to less than 4 megabits per second. That's huge. That's below Netflix's recommended HD streaming rate, just a slight amount of packet loss. And as you can see, if you look down that third column, when you introduce packet loss to the network and latency, it gets worse and worse and worse and crushes throughput. You can have the best equipment in the job, you could have the best programming, best engineering, and if you can't get the throughput, the experience is ruined. Now let's look at just latency without packet loss. So latency, when you introduce 30 milliseconds of latency, your throughput goes from 94 to 16 megabits per second, which is less than the 20 to 30 that Netflix would require for 4K streaming. So all of a sudden it's lost. And where you really see this is with Wi-Fi connections. If you've got bad wireless, you're going to see 70, 80, 90 millisecond throughput. And if you look at that 90 millisecond throughput rate, it's 5 megabits per second. There's no way you're going to be able to stream multiple streams of HD content in that case. So latency and packet loss really do impact your networks, and it's something you want to pay attention to. And there's a few ways you can measure latency and packet loss. And this applies to both the WAN and the LAN side of things. On the WAN side, look at your ISP speed tests, and we can measure latency on that. We'll also show you upload and download speeds. So that's something you really want to pay attention to and make sure they're getting the throughput that's required for the services your customers are streaming. So IHEG's got an internet speed test. We leverage the speed test on that servers, so we just run that automatically for you behind the scenes 4 times a day, and you can see averages and spikes and peaks and valleys and things like that. So make sure you pay attention to the WAN side, because if you've got a bottleneck at the WAN side, then your streaming services are crushed. You could have the best LAN if they're trying to stream Netflix, but there's a choke there, it's ruined. But then the other thing you want to look at is what's my local latency and packet loss, and ping is a great way to do this. IHG does a base ping on every single device. That's how we measure throughput and performance. Ping the local devices, look for packet loss and latency, and you're going to easily see this. Our basic webinar goes into detail on this tool, but that's a great way to measure packet loss and latency locally. A very, very common question is, well, what if I see packet loss and latency? What do I start doing, especially on my ISP? If my ISP's latency is going to 50 milliseconds or 100 or 200 or even 1,300 we see on these things, how do I start to troubleshoot that? I'm going to talk about an example using a cable modem. Log in your cable modem's configuration page and check its signal strength. And you'll see SNR, signal noise ratio, and power levels listed there. And you need to make sure those correlate to what is needed. This is my house where I was troubleshooting some issues recently after I put in some splitters to try to use an over-the-air antenna. And I had so much loss that my internet became unreliable and started doing a lot of packet loss and latency. So I pulled up this page, and this is why. We're getting 32 and 29 dB SNR, which is below the minimum threshold at 256 QAM modulation. I pulled that off the internet, so not going to get into specifics of that, but 33 is the recommended value. You see, I'm not hitting that value, so that's why my internet was being so poor. So I took the splitter out, and those numbers went up to 33 and 33, and the problem was solved. Also, when I took the splitter out, my SNR, which was or my power level, which is in a reasonable range, -12 to +12 is recommended, and I was at -9. The closer to 0 you get, the better. When I took the splitter out, I went down to -6 on each of these. So when I did that, I saw a noticeable improvement. The internet got better. My latency and packet loss went away. That's a perfect example of how you can troubleshoot that kind of thing. So I think that's a really important example to look into. The other thing you want to have the ability to do is see all the devices on your network, because we're going to start talking about remote management and why this is important. Use a network scanning tool like Fing or IHG Network Scan, and you can see all the devices in the network. So if you're not familiar with these tools, Fing, Angry IP Scanner, Advanced IP Scanner are all great tools. IHG's got one built in. You can look and see, well, did the Apple TV stop working because the kids came home from vacation and factory reset the unit, and no longer can we control it because it's not at that static IP address? Let's run a network scan and see where we can see it. Maybe that's why it's showing 100% latency, because it's no longer at that IP address. So those are the types of things you want to look for. What this all leads you down the path of is the ability to fix more problems at home or from your office. The point is, you don't want to jump in the truck every time one of those 25 devices in the network is having problems. You want to be able to look back at history and see what's going on. You want to be able to emulate things remotely and try to fix things remotely without rolling a truck, because as we get more and more devices in the network, rolling a truck isn't feasible. It's expensive, it's time-consuming, and it's not going to fix the problems. So the things you want to think about with remote troubleshooting are reboots. Reboots are really important. You were talking about $99 consumer electronic devices, or they even dropped the price of Apple TV, so it's not even $99 anymore. The point is, a $99 device is going to lock up, but it's got so much value and it's hard to deny the experience the customer gets with it. You're going to use them, so make sure you can reboot that when it does lock up. You want to be able to ensure you can do basic network troubleshooting remotely, where you can emulate problems and emulate programming commands remotely if it's not working. So you check the network, everything looks good. You check the device, everything looks good. Okay, let's check the network, or let's check the program and make sure my signals are going. You want the ability to look back over time and see what happened even when you're not actively looking at things. So make sure you're logging enabled and have devices that are checking things 24/7 and logging that information. Because what you want to look for is patterns. Are there other devices that are having problems at the same time that the Apple TV is having problems? And do they share something in common, like the same access point or the same switch? Are 5 customers in the same neighborhood all having internet latency around the same time? Maybe it's a networking problem with the ISP in that local network that's having issues, that regional network. You want to be able to just check whether the device is online. That's very important, because people unplug things or things get kicked loose, and that happens. So all these kind of things you want to think about, because what it comes down to is you should be able to fix the majority of your problems without ever rolling a truck. And if you do need to roll a truck, you should know exactly what you're going to look at, because something is probably dead at that point. So you send the right guy with the right parts, and you get things done a lot faster. Next thing I want to talk about are some remote access methods. And really these are the most common: port forwarding, VPNs, SSH, remote access servers, and the IHG Connect Ninja, because I think all of this is really important. The first thing is most common is port address translation or network address translation, which is basically port forwarding. Port forwarding is really, really common, but you need to stop doing it. It's the least secure way of accessing your networks. It leaves those devices wide open to the internet, to hackers, to vulnerabilities, to scans. We're talking about cameras and things that are really critical. You don't want those things open to the world. Even with the best usernames and passwords, exploits can work around that. So if you're port forwarding, stop it today. It exposes your systems to hackers. Talk to your manufacturers, figure out other solutions. We'll talk about some of them right now. And this is something your customers are going to ask you about. They're going to read it in Forbes or Wall Street Journal or see it on Fox News that talks about how homes are being hacked and what can you do about it. And usually homes are being hacked because of port forwards. So if you're using things like port forwards for camera systems, get a camera system that has a cloud-based portal or set the customer up on VPN. You need to do one of those two things. Don't port forward. There's plenty of other ways to do remote access. Cloud-based is one of them. VPN is the other. Those are the two most secure. If you need to do port forwarding or you need remote access for troubleshooting and support, that's where IHG's solution comes into play. A lot of guys still do port forwarding for IP power control, and that's, again, a very, very bad idea. So IHG, what we do is provide a secure gateway to the cloud with our small appliance, so you can do a lot of these things remotely without port forwarding. The first thing you can do is you can do all of your reboots. So you can do IP PDUs, reboots through the Envision portal without any port forward or firewall configuration. And what that makes is secure power management across a number of different vendors. So we work with all the companies you're probably working with. We generally support as far as our IP power products. Managed PoE switches. We give you individual port power cycling. So you can power cycle the IP camera or the control processor through the switch without taking the entire network down and then rebooting the whole switch. We can even soft reboot certain devices like Sonos receivers and control processors. So cloud-based reboots are really important. We also give you full remote access, and this is key. Without port forwards, it's very difficult to do. So we have a tool called the Connect Ninja, which gives you full remote access to any TCP port on any IP device at that site. So if you need to change a program, SSH to something, RDP, you can pull up a full remote desktop connection through our Connect Ninja securely without port forwards. So these are the types of things you want to be looking at. If you're using Mac or Linux, we can do VNC. We can even hit some touch panels that run VNC servers, all without the port forwards, so you can do support remotely and securely. And this is a great one, kind of shows the power. I can SSH to a device and have full command line capabilities. If this is a Crestron processor, I could emulate commands. If it's an AMX processor, I can send command to virtual device XYZ. You can do those types of things through a solution, again, without the port forwards. A lot of things like changing automatic reboots on that watt box can be done through here. Changing switch configurations, that's important. That can be done through here. Changing VLAN associations, looking at port status. And I talked early on about why managed switches are important, and this slide really helps illustrate that. You see the individual port status, whether that device is linked up, is here. So if the device falls offline, what do you want to do? You want to check and see if it's got a link light to begin with. And if that's not there, well, then either that port in the switch is dead or somebody unplugged it from the network, or that device is offline entirely. So that's what you want to look at. But also on a managed switch, you're going to look at port drops and errors, and you can see all kinds of different statistics on the device. So managed switches are really, really helpful. And you can do all that configuration through Connect Ninja. Another great thing that guys like is you've got VPN set up to the site, but Comcast or Time Warner makes an upgrade to the router, and that factory resets it, and all of a sudden it's not in bridge mode anymore, which means all your port forwards or your VPN is useless. So you have no more remote access. What do? With the Connect Ninja, we can work around that. You can then Connect Ninja into that cable modem and change it back to bridge mode, and it'll come back and everything will work the way you want it to. So another common use. VPN is the most universally supported method of secure remote access. So there's a number of different ways you can do VPN, but with a tool this powerful becomes a high level of responsibility. You want to reserve VPN usage for your IT administrators only. This isn't a tool that every single technician should use just to reboot a device. And it's not a tool that every programmer should have to use just to load a program, because management of usernames and passwords on a VPN becomes very difficult. And what happens is a lot of you have one username and password for your entire company, and that gives anybody in the company that username and password access to all of your sites. And if somebody leaves the company, it's hard to go back to 500 routers and change that username and password. So avoid giving that out to anybody other than your IT admin. If you change the username and password for every single site, you need to be able to audit and see, well, who's doing what, and VPN doesn't really give you that access. When somebody's in there on VPN, they generally have full-on audited access to every single device on the network. You need to be able to securely store the passwords if that's something you're using. Don't store it in your group calendar or shared contacts Outlook that everybody in the company has access to, because that's no better. So VPN is very powerful. I highly recommend using it, but only as your tier 5 tech support kind of thing. So you should have to escalate it all the way up the chain to your IT admin at that point, and he's going to do the VPN troubleshooting at that point. So it should be reserved for top-level access only, and that username and password should be kept very, very secure. So that's VPN. I want to take a minute to look over the questions. I think I've been answering most of them as we go, but give me a second and I'll review this. So yeah, there is a question about supported IP power managed switches, other gear that work well with IHEG. That reference network list that I showed early on is a great one. But generally, if the device supports SNMP as far as managed switches go, we support it. And the same goes for routers. We work with any IP device because we're measuring network latency, packet loss, throughput, ISP scanning. So as long as the device has an IP address, we can help you. Now, SNMP gives you further visibility, which we'll talk about towards the end of this. But that's the kind of the best practice. If it's got an IP address, you can manage it with IHEG. If you do want to do IP PDU control, like for IP power, we work with over a dozen different manufacturers' products, and we're adding more on a regular basis. There are some specific questions about certain manufacturers, Control4, Crestron with Connect Ninja. There are some limitations. I would just encourage you to go through support to understand them a little more, because I see quite a few questions on this. Generally, the Connect Ninja only supports a single port, so if the system requires 2 different ports to operate simultaneously, like FTP, for example, and then, like, unfortunately, Connect Ninja today doesn't work with that, but FTP is not broadly used anymore. And for certain instances, like Crestron, for example, Toolbox will work on a single port. So if you want to do a Toolbox, you can do that, but I think for a remote emulation of the touch panel, you need 2 ports, so that would be a limitation of it. So if you've got specific questions on that, please just submit a tech support. There's only a handful of devices that we have issues with. All right, in the interest of time, I'm going to keep going here. The next thing we're going to talk about is remote monitoring and management, because I think with the growth of all these devices, this is really, really critical. And this is a feature within IHEG Envision, is the remote monitoring and management side of things. There are other tools, but the point is you should be using something to know about the problems on the network before the customer does. Because if the customer is noticing it, they're probably calling a competitor, or they're calling you screaming like this because something's not working. So the idea is you're getting better insight to your systems, knowing about problems before the customer does. You can do more remotely to solve those problems and hopefully maintain a really, really good, positive client interaction. The basics of remote monitoring is, number one, you want to look at that latency and packet loss. I think we beat that one to death, so I'm not going to talk about that more, but let's watch that first. The next thing you can do is look at certain services on that device which are critical, like check TCP ports to make sure it can be controlled. Check the web server to make sure, yes, well, it's on the network, but is it responding to software requests and things like that. So these are some common ports you can look at on certain devices, and a lot of this kind of crosses over to the small business space, so not all of it's used in a home. But to give you an idea of what you might look at, the most common way of doing remote network management is using a protocol called SNMP, which I've mentioned a few times but haven't really explained. SNMP stands for Simple Network Management Protocol. And unfortunately, it's not as simple as the name might imply. It can become pretty complicated, but once you get a good grasp of the acronyms within SNMP and how it works, it's not very difficult. And we've got some great videos on like YouTube that explain how to use SNMP and how to do an SNMP walk on your devices. We also get into a lot more detail in SNMP on our advanced webinar within this series, but what you should be looking for are common acronyms like OID, or the object identifier. That's how you extract something like temperature or bandwidth, or error count from a device. A MIB is a management information base, which is basically a dictionary which links, and you say, okay, well, I want to look up temperature, and it's going to give you the OID, which corresponds to temperature on that device. So you're going to go to your manufacturer, like Christy, and say, I want to monitor bulb life hours, and I know you support SNMP. Can you give me your MIBs? They give you the MIB. You go on that MIB, you see is bulb life in there. There it is. You copy and paste that OID. You put it into Envision, and now you can monitor that bulb life and alert on that threshold. There are different SNMP versions, V1, V2, C, and V3. Most commonly used is 2C, especially in our world, so that's one you want to pay attention to. You'll see a term called SNMP communities, and basically it's a shared password. So to extract information, you want to have a little bit of security on there, so you put in a password. And the basic password is usually public. It's not very secure, but a lot of times the information is just like packet counters, so it's not like security is an issue. So there's usually a read community, and that by default on most devices is public, and there's a write community by default on most devices that's private. What the write community allows you to do is control that device, and generally control means I can turn a port on and off on that switch, and that's about it. You can always overwrite those two communities, but know that there are two different ones usually, especially with version 1 and 2C. There's a public and a private, and a read and a write, and usually the defaults are public and private. There's a tool called SNMP Walking, which basically will show you all the SNMP information on a device. And I wouldn't start with SNMP Walk, but if you're curious, do an SNMP Walk on a device, and it's going to spit back a ton of information. You'll probably be amazed at how much information it'll tell you. The better place to go for that information is your manufacturer and ask them for the MIBs. And there are GUI tools, which we really like. iReasoning MIB Browser allows you to do the SNMP walk in a nice, user-friendly fashion. So this is SNMP, and this is something you should probably start to learn about if you're going to do remote network management and monitoring. And hopefully, after everything we've talked about today, you're doing that or are planning to soon. So what can SNMP expose? And this is really, it depends on the device. Number one, the device has to support SNMP. And unfortunately, the world is still adopting this as a standard in the residential world and consumer electronics world. So we're seeing it more and more, but it's not widely adopted yet. The networking equipment, the power equipment generally does support SNMP, but things like Apple TV do not yet. So on devices that do, the type of information you want to look for are things like firmware. You can extract what firmware version this is running. And that's great if you want to audit and see who needs an upgrade. You can monitor things like bandwidth utilization on a switch, fan status on the switch, see if the fan died, how much memory is being used in the device. Is the processor overloaded? What's the temperature in the closet? SNMP can extract a lot of really useful information. So it's helpful. One of the things IHEJU does is help you filter this out and understand what information is important on a device, because if I was to do an SNMP walk on a switch, I might get 3,000 lines of information, and then you have to parse through it. We take care of a lot of that parsing for you. There's another tool that you might come across, especially in the SMB world, if you're doing businesses, and that's WMI. WMI is Microsoft's adoption of SNMP. Of course, Microsoft doesn't like to stick to the standards. They had to go out and recreate the wheel, and they did that with something called WMI. And there are some benefits here for sure, but for what we're usually doing, WMI is just a replacement to SNMP, so you can extract things from Windows workstations and servers like free space, drive status, memory free. Important information, but you may come across that as well, so I wanted to mention that. We get a lot of questions on why can't we just use this IT product and apply that to the home. And really, if you look back at the history of a company, that's how we started. These IT tools are very complex. They have more information than you'll ever need. They're very expensive. They require on-site servers and infrastructure. I wouldn't recommend it. So if it's something you guys are entertaining or something the IT guy in your company is saying, well, I could do this with XYZ tool, just understand the complexity and the expense that you're getting into. These tools weren't designed for it. They're really designed for server management on-premise and enterprise campuses, not for distributed locations on homes and businesses. With that, the other thing that's a little concerning as an owner is that the person who really understands this is typically that one IT guy, and if something ever happened to that IT person, all that knowledge goes with them. So it's a pretty common question. I wanted to address it today on the intermediate webinar because it does come up here and there. But things to think about when looking at other tools for remote monitoring. IHEJU was custom built. because what happens is you'll have a tool from SnapAV and you've got a tool from Panamax. Those two companies are very good partners, and we integrate with both of those tools. And then you've got a control tool from Control4, another from Crestron, and then again, two good partners of IHEG. And then you've got tools for your Cisco equipment and your Arachnus equipment, two more tools. Well, that's 6 different tools you're having to manage within your company for troubleshooting. All of a sudden, troubleshooting and support gets really complex and starts to become a headache. What IHEG focuses on is maintaining those good relationships with as many manufacturers as possible and making the management easy for you, because you don't need any more complexity in your lives. So the other thing that I think is important to point out is you do see a lot of manufacturers developing their own solutions. Again, these are all generally partners of IHEG's. What these guys focus on is enabling their own products for remote management. And when we talk about getting away from port forwarding, this is what they're doing. They're saying no longer do you need to port forward to do remote reboots of our software and do network configuration of our tools and to access our cameras. We've got a portal for you. And the portal helps the customer access all of that too. So this is all really good stuff, but it's not meant to do your day-to-day Tier 1 and Tier 2 support, because very rarely are you doing just SnapAV equipment or just Blue Bolt products or just packaged products. You're probably switching between manufacturers based on availability, based on what ref you liked at the time. There's a number of factors, and what IHEG really does is focus on helping you with Tier 1 and Tier 2 support across all of your vendors, not enabling their products. When you need to get into remote access to the cameras, that's when you would rely on their service. So a lot of guys think we're competing. I really don't think so. I think it's very complementary to everything they're providing. So again, a very, very common question. One of the last big topics I want to get into today is VLAN information. VLAN is a pretty commonly used term in our industry these days. What VLANs require is a router that will support it, as well as a switch that supports VLANing, which means it has to be a managed switch. And I'll say this, I think it's really important to understand this. Although VLAN is a standard, the way that VLANs are configured vary greatly between manufacturers. So if you go to Cisco and try to configure a VLAN, it's going to be very different from if you go to an Arachnus switch and try to configure a VLAN. This is why I think it's important to stick with one manufacturer. Once you find it, don't change if you can help it, because you're going to have headaches trying to remember how you configured it or what the gotcha is with this device configuration. The reason that it's very tough to find a VLAN course from a manufacturer or from CEDIA is because the configurations are so different. So we could teach it for Cisco, but we know a lot of you are using other products, and therefore that class would be worthless. So rely on your manufacturer for the specific training of configuration. What I'm going to talk to you about today is principles and why it's important and where you should use it. So VLANs are great because they add performance and performance, reliability, and security to your networks. It's basically, if you've been in the industry long enough and you think about networking when it first hit the control world, and you were installing a Crestron system on the network, and you're also installing a Kaleidoscape system on the network, those two manufacturers would say use 2 different switches and put all of your Kaleidoscape on one network and put all your Cisco on the other network, all your Crestron on the other, so the two don't interfere with each other. And that was a good solution at the time, but really what VLAN solves is that problem. On a single piece of hardware, I can now segregate traffic out virtually and create multiple virtual LANs, so that I have one switch, but I have 2 virtual networks so that they don't interfere with each other. So it allows you to segregate traffic. Things like VoIP, data, setup, AV control, guest, can all be segregated out into their own little networks where they don't interfere with each other. You can give some networks priority over others. They usually share the same internet connection. That was a common question. So although you've got 5 different VLANs, they all go out to the same router, which share the same internet connection. You don't need 5 different internet connections. Typically, each VLAN has a unique subnet, and this just makes for easier management. So VLAN 1 is 192.168.1.x, and VLAN 2 is 192.168.2.x. So when you look at that device and you look at its IP address, you know which VLAN it's on. So it's not a requirement, but it's pretty common for design. You can do virtual SSIDs and have those devices on different SIDs have different VLANs as well. You can bridge VLANs. So just because a device is connected to a certain VLAN doesn't mean it can't access other VLANs. You can create routes and firewall rules to allow certain traffic between VLANs. And the other thing to know is VLANs can be assigned by port or role. So you want to look at the configuration. Most commonly in our world, it's a port-based VLAN association, but there's also tagging of devices and other more advanced topics that we can get into. But generally speaking, it's going to be port-based configuration in your switches for the things we're doing. So that's when you would use VLANs. VLANs are pretty complicated to set up and maintain. It adds an extra layer of complexity for changes, for troubleshooting, for ongoing management. I wouldn't recommend using a VLAN for every single network you do. If the network is big enough and you have concerns over reliability because of packet collisions and security, and you want to segregate it out logically because you're out of address spaces, those are the reasons to use a VLAN. If you're just installing 25 devices in a site or 20 devices in a site and they're all pretty light in traffic and you're not really worried about control interfering with the video streaming, VLANs might not be the answer. If it's a small network of 5 devices, VLAN's probably not the answer unless there's a very specific reason. So what I will say is use VLANs when needed, not all the time. And here's kind of an example of what a VLAN design might look like. You've got VLAN 0, which is your management VLAN, where all your switches, all your access points, all your router lives. That one has ability to access any of the other 5 VLANs. VLAN 1 segregates out your voice over IP traffic. VLAN 2 is your general data traffic. VLAN 3 is your control. 4 is guest, and 5 is video distribution. And you can see each one of these VLANs has their own address space. So when you go to those devices, you can see which VLAN they're on. So that's how a VLAN would be designed and segregated. It's pretty straightforward stuff. I mean, the concepts that I just talked about, I think, are pretty easy to grasp, but unfortunately, the implementation gets a little more difficult. And as I said, it's not standard across manufacturers. So when you get into this and when you learn it, make sure you stick with that manufacturer, invest the time to relearn the new one you're getting into, because that can create big headaches. One of the last few topics I'll talk about quickly are Wi-Fi issues. I mentioned that high packet loss and latency are most common on Wi-Fi devices. If you're doing wireless control processors, touch panels, IP cameras, wireless Apple TV units, and you're seeing latency and packet loss, that's something you want to pay attention to. Now, how do you address that? You can do something as simple as going out there and changing channels and see if that fixes it and doing it blindly. But a better way to do it is rely on tools like Insider or WiSpy. These are both made by MetaGeek. What Insider does is show you all the different other access points that are out there within range, what their signal strength is, where you're standing with either your phone or your laptop, what channel they're on, so you can see if it's interfering with the traffic, and allows you to optimize the layout of your network. And if you're doing individual access points around a house still without a controller, this is really important to do because you want to do proper network layout and design. You need a tool like this. If you're using a controller-based solution, you probably will use this tool just to troubleshoot the outskirts and see what kind of interference you have coming in. But the better controller solutions manage all this for you automatically. But if you're troubleshooting this, especially on older jobs, it's a great tool to have. It's free. The older versions are free. I think they moved to a pay model for the newer versions, but the older versions are still available out there. And then the other tool, which I think every single company that touches Wi-Fi should have, is their WiSpy tool. They've got a 5 gigahertz, 2.4 gigahertz tool that I would recommend getting, so you're not buying something that's going to be outdated really soon. And what it shows you is interference from devices outside of just the Wi-Fi devices, because Insider shows you Wi-Fi, but this one shows you anything in the 2.4 and 5 gigahertz spectrums. It's going to show you microwave oven interference. It's going to show you baby RF monitor interference. It's going to show you Zigbee network interference, and it's going to help you do intelligent design and troubleshooting at a very, very low cost. And these are proactive. You probably need one for your company. The technicians checking in and out when they need it. But 2 really good tools to have, again, by MetaGeek. You can order them on their website. Another thing you might want to consider is if you're doing all this, putting network-attached storage in for backups, and you're probably doing this as your NVRs. You can also consider cloud-based backups for your customers. These are 2 things that are becoming more common. Carbonite and Mozy are probably the most popular, but you can also create your own solutions with like AWS. Not nearly as common, but if you're doing all this, I would recommend it. Storing some of your program files in the NAS isn't a bad idea. So it's always there and reliable. Dropbox, again, is another thing that I see a lot more integrators using. And finally, I think this is really, really important. LastPass and KeePass are 2 really good password management tools. Stop documenting usernames and passwords in spreadsheets and notebooks and a text document in Outlook, in your email, and on your desktop. It's not the place to do password management. It's a very, very big problem, and it's going to become a bigger problem as the network devices continue to grow in scope and importance. These tools like LastPass allow you to revoke access to passwords from your technicians. They allow you to share certain passwords with just certain technicians, and then you can take it back from them. Somebody leaves their company, delete their LastPass account, they don't have all of them. I believe the enterprise tool has an audit trail, so you can see if an employee left, what passwords they were accessing before they left, so you can try to see if they were trying to do something malicious. The point is, if you're at this point, you should all be using a tool like this. And your usernames and passwords shouldn't be standardized. They should be stored somewhere secure. This is a tool we've used for a number of years that we really like, and I recommend. 1Pass is another, but I can't recommend this enough. So to wrap up, man, that was like a fire hose of information. We're going to probably split some of this out into more digestible chunks of information over time. So I'm not just throwing it all at you because we keep adding to the slide as the network becomes more critical, or to this presentation. But there's plenty of places to go for more information. Our Networking Essentials series has the beginner and intermediate courses right now. And as I just mentioned, we'll be adding more to it and kind of breaking things out so you can just watch a clip on this topic or watch a clip on this topic and not the entire thing. Leverage your manufacturers. I said this a number of times. If you're doing Cisco, go to Cisco and get trained on their product. If you're using SonicWall, go to SonicWall. If you're using Package, go to Package. Get to know those products really, really well. Get your technicians trained. Every one of your technicians should know the information in our basic class. So our 101 Networking Essentials course. I think every technician in your company should have those types of topics: IP addresses, subnets, gateways, DNS, what they're used for. Leverage CEDIA. CEDIA's got some great training, which I help contribute to. Wikipedia is a great source of information. If you just want to know what an acronym means, go to Wikipedia. Leverage companies like Access Networks and Reboot for your enterprise-grade devices. And even if you don't use them, you're going to learn quite a bit from them. So if you're curious, give them a call, and you're going to learn something. It's going to be well worth your time. There's plenty of other tools on the internet. CompTIA is a IT industry association that we're a member of, which also does networking training and computer training. And another one I love is partner with the IT guy in your neighborhood, because what that allows you to do, if you get in over your head, you've got a crutch. If the customer's asking you about 802.11ac and you've never done it, partner with the IT guy and say, hey, do you mind engineering and installing this network for my customer? They want it, and I've never done it. And he's going to do it, and you're going to learn from him. And the next time somebody asks you about something new that you don't know, you can do the same thing. And what will happen is you'll become a source of referrals for each other. So I think it's a great, great way to do it. Just realize that don't let them do everything. I think this is a core competency that we all have to have within our businesses. And if you partner with somebody like Access Networks who specializes in residential, because if they come from the enterprise world or the business world and they try to apply the same principles to the entire network within the home, they're going to run into problems. So I encourage you to keep learning. CEDIA's got a residential networking specialist track now, which I again help them develop. So I think it's pretty good for your everyday technicians who want to learn networking. There's definitely, they can go above and beyond this. If you have an IT guy, this is probably, the 400 level courses are probably going up to the level he already knows. So again, at some point you want to step over to your manufacturers and say, okay, where do we go from here? But check out the CEDIA networking specialist. There's online education now as well. And I'll wrap up. What about recurring revenue? Because I think all this offers a huge opportunity to earn recurring revenue. Because the challenge with a lot of those products that I recommended on the networking side of things is your margins are pretty low. And the IT industry has adopted a recurring revenue model to work around this. As their margins continue to shrink, they've started putting in recurring revenue, what they call managed services. And what something as simple as a RMR opportunity for your company might look like is, with every one of our networks, we sell a managed network service offering that ranges in cost from $19,000 to $19,000 a year, depending on the size of that job. The managed network offering is very simple. It's remote network management subscriptions. You do LAN, WAN speed testing for the customer, so you're doing ISP speed tests. You'll reboot devices for free. If it takes less than 15 minutes to reboot it, you're going to do it for free and not charge them because they're paying you annually. You're going to do 15 minutes of remote support for free without charging them. Anything beyond that, you're going to charge. And you're going to do Wi-Fi monitoring to know if their Wi-Fi network's having issues. And again, you can sell that. This is just an example. We're not going to talk about IHEEGE pricing today, but I wanted to give you an idea of what a very, very basic network management package might look like that you can now sell with every one of the networks you sell. So every router in DTools has a network management service offering attached to it, and it could look something as basic as this. Small networks are only $20 a month, or medium-sized networks are only $30 a month, and our larger networks are $50 a month. And obviously, there's a lot more you could add to this, where we see guys in California with $20,000 network management and service contracts, but it's a great place for you to start. Because unfortunately the world's not changing. This is where we are today, but get ready for this to become even more complex, where everything that you guys are installing is leveraging the network. It's all getting less expensive. That means the opportunities out there for us to reach customers we never had access to is growing, but with that growth, you need the proper tools and knowledge in place to handle it all. So hopefully today's webinar taught you a lot about that. That's about my hour, so I want to say thank you to everybody for your attention, for your time. Hopefully you learned quite a bit. I'm going to stick around for a few minutes and answer questions. I'll also remind you that we didn't do any kind of IHEEGE demo today, so if you really want to dig into the tool, just go to our website, and on the front page, click the big green button, say Schedule Demo. Thanks again. I see there are a few questions, so give me a second, and I'll answer some of those.